We all make phone calls, right? It's something we do every single day without even thinking about it. But have you ever actually stopped to wonder what's going on in the background? It feels like magic, but it's really this mind-boggling journey. In this explainer, we're going to follow your voice on its incredible trip across the globe, a trip that all starts the second you hit dial. Yeah, it feels totally instantaneous. You dial a number and bam, just a few moments later, you're connected. But that one simple action actually kicks off this lightning-fast chain reaction across a huge hidden network. So where does that journey really begin? Well, believe it or not, it all starts with a physical connection. It's called the subscriber loop, and it's literally a dedicated pair of copper wires that run from your house all the way to the local telephone exchange. This dedicated line is also why an old-school landline phone can often work even when the power's out, because it gets its juice directly from the exchange, not from an outlet in your wall. All right, so your call has officially left the building. Now it enters the very first point of intelligence in this whole system, the local exchange. You can basically think of it as the central post office for all the calls in your neighborhood. This switching office, or exchange, is where the real action starts. I mean, it's not just some passive junction box. It's the actual brain of the local network. And it has a very, very specific checklist of things that it absolutely has to do for every single call that comes through. So to handle every call, the exchange has to perform this set of 7 essential functions. Now, you probably think the acronym for something this technical would be, well, technical. But the engineers who built this system, they gave it a surprisingly memorable name. Borscht. Yes, really, just like the soup. Let's break it down really quick. B is for battery feed. Yep, the exchange powers your landline. That's the secret. O is for overvoltage protection. From stuff like lightning strikes. R is for ringing. Pretty straightforward. S is for supervision, so the network knows if you've picked up the phone or hung up. C is for coding, which turns your analog voice into a digital signal. H is for hybrid. Hang on to that thought, we'll come right back to it. And T is for testing the line. Every single call gets the full Borscht treatment. So this brings us to a really fundamental challenge. That simple pair of wires running from your house has to carry your voice and the voice of the person you're calling, all at the same time. So how in the world does the network untangle all of that? Here's the core of the problem. There's a basic mismatch. Your local line, that subscriber loop, is a 2-wire system. Talking and listening are all jumbled together on the same path. But the main network, the big backbone, is a 4-wire system with totally separate dedicated paths for sending and receiving. It's kind of like trying to merge a busy 2-way street directly onto 2 separate 1-way superhighways. The solution is just a brilliant piece of engineering called a hybrid circuit. Remember the H in Borscht? Well, this is it. It acts like a super smart traffic cop, taking that combined signal from your 2-wire line and splitting it perfectly onto the separate send and receive lanes of the 4-wire network. Just amazing. Okay, so our call is now in the right format for the big network. But now, how does that network find the one specific person you're trying to call out of literally millions of other people? It's one thing to connect a phone to its local exchange, but it's a completely different problem to connect thousands of exchanges to each other. You can't just run a wire from every single exchange to every other one in the country. That would be absolute chaos. Now, the ideal solution might seem to be what's called a mesh network, where every exchange has a direct line to every other one. And yeah, that's super resilient because a call could take all sorts of different paths. But the number of connections you'd need grows exponentially. For a big network, it just becomes impossibly complex and crazy expensive. So the much more practical solution is the star network. Instead of connecting to each other directly, local exchanges all connect to a central, high-capacity hub called a tandem exchange, which is basically an exchange for other exchanges. And then those hubs connect to other hubs, creating this much more organized, scalable system. This whole system works perfectly for local and even national calls. But what happens when your call has to cross an ocean or an entire continent? That is when some truly amazing technology has to come into play. To go the distance, the network uses some pretty incredible stuff. I mean, your voice might travel through these massive cables laid on the bottom of the ocean, or get beamed between towers using microwaves, or even get bounced off the Earth's atmosphere. Or it might get launched right into space. And when we say space, we mean way up there. For satellite calls, your voice is turned into a radio signal, beamed to a satellite that's in orbit 36,000 kilometers above the Earth, and then sent all the way back down to its destination, all in a fraction of a second. So, with all these different systems and networks connecting all over the globe, there's got to be a set of rules, right? A global rulebook to make sure a call from Tokyo to Toronto has the same quality as a call you make across town. And you bet there are. There's an international body, the CCITT, and their entire job is to create the recommendations and standards for the global telephone network. Their main goal is to make sure every call is high quality and reliable, no matter how many borders it has to cross. And one of their most important rules, one that dictates the complexity of any international call, comes down to a single number. That number is 12. So, what's the deal with the number 12? Well, the official recommendation says that to maintain good call quality and to prevent stuff like signal loss or weird echoes, any single international call should be routed through a maximum of 12 distinct circuits. It's a surprisingly simple rule that governs a massively complex global machine. The telephone network really is a marvel of engineering that we totally take for granted. It's this invisible web of wires and hubs and signals that connects every single one of us. And it just makes you wonder, what other incredible invisible networks are humming away right under our noses, powering our modern world?